So welcome everybody to this latest video on 162 Math, and in this video we'll be going over a quick topic test with a collection of some GCSE exam style questions on all things related to graphs at foundation level. Now a copy of the questions for you to have an attempt at before watching through this video is available for you to download by clicking on the link in the description, which I strongly recommend you do to see how much understanding you have on this topic. Now, as like with many of these tests, there is no indication about whether these questions are specific to a non-calculator or calculator paper. So what we'll do is we'll just assume that they are non-calculator and ensure that we are showing as much working out as possible. So let's get started on question one. So question one says here are four graphs, and we've got graphs A, B, C, and D, and they've been plotted for us. And it says these graphs will help you answer questions 1 to 5. So the first question says which two graphs are parallel. So the definition of two parallel lines are when extended, they will never meet and have got the equal distance or equal perpendicular distance between the two. So from this, you should have established that the two parallel lines are lines B and D. Let's just get started by writing those. Now, when you're writing two options, it doesn't really matter what order you write it in. I'm just going to go for alphabetical order, but if you wrote DB, that would still be fine. Looking at question 2, it says which two graphs are perpendicular. Now the definition of perpendicular are two lines that meet at 90 degrees. Now obviously, depending on whether you've printed this test or you're looking at it on a screen, it may look like it's not perfectly perpendicular, but I would say of all the lines that are drawn there, the two perpendicular lines are going to be A and C, where this there is 90 degrees. So let's just go about writing A and C. For the next one, it says which of the following points does graph B not pass through, and it says circle your answers. So let's have a look at each of the coordinates. So the first one is 0, 6. So if we go up the graph, we've got 0, 6, which is there. So that does hit line B. Our next coordinate is minus 3, 9. So minus 3, 9, where it's going to be minus 3 is here. So 9 is going to be up there. So that one's a bit of a question mark, but I would say that it's a good chance that that one will. So let's just put a question mark there. Let's put across there. Then we've got 3 minus 3. So 3 is here and minus 3 is over there. So that definitely does not, never in a million years is that going to touch line B. So that one there is our incorrect answer. You might want to check with regards to the fourth option, but that one does hit the line. And so that one is true. Now I've put a cross on there. So let's just put a little tick there. That one does meet. So again, the only question mark would be the third one. Another way of doing it is if you actually use the equation. So the equation for graph B is, let me just go back up to have a look at it. It is x plus y equals 6. So if we've got x plus y equals 6, so if we substitute these coordinates, I've got 3 plus minus 3. Does that equal 6? No, because that equals 0. So therefore, it's not going to be true. Whereas if we did this one, if we weren't too sure, does minus 3 plus 9 equal 6? Yes, it does. So that one does actually lie on line B. The next question then says, write down the solution of the simultaneous equations of 2x minus y equals 1 and x plus y equals 4. Now, if we want to use the graph, what we're trying to do is find which two graphs lines could be rewritten as each of these. So if we look back at the original equations, which one does it resemble? Well, the top one looks like graph A and is graph A. So this one here is graph A or line A. And which one resembles the bottom one? I would say that's going to be graph D. And so this line here is graph D. So what you're looking for when you're solving simultaneous graphically is you're looking at where the two lines intersect. So looking at line A and D, they both intercept at this point here. So the answer is going to be that coordinate. So it's going to be minus 1, minus 3. So let's just go about writing that. So minus 1, minus 3. And then for question 5, it says work out the y or coordinate of the point on line C with an x coordinate of 10. So if we look at the equation for graph C, so graph C is 2y plus x equals 1. So then if I substitute x equals 10 into this, I end up with 2y plus 10 equals 1. Then go about solving this. So that equals minus 9. So y equals minus 4.5. So the answer then is going to be minus 4.5, or you can write it as minus 4.5. or you could write it as -9/2. Moving on to question 6, it says point A and C are drawn on a centimetre grid. A and C are opposite corners of the square ABCD. Work out the area of the square. You must show your working which may be on the diagram. So let's first of all work out where those two coordinates are going to be. So this is where B is going to be, and this is where D is going to be. Now there's several ways in which you can work out the area of this square. Let's just start by just doing a little sketch by joining those coordinates up. And hopefully yours will be a little bit more accurate. So what we need to do is work out the area of this. Now, one way of doing this is to, using the diagram, is to look at it as triangles. Now the area of this triangle, that's half of 3 squares, so that's going to be 1.5. This triangle here is going to be the same, so that's also going to be 1.5. This triangle here is also going to be 1.5. And this triangle here is also going to be 1.5. Now, if you're not sure where the 1.5 has come from, well, if I just shade in these 3 squares, you can see that the green line splits those 3 squares into halves. So half of 3 is 1.5, which is where that 1.5 comes from. So then moving on to the next bit, we've then got to work out what this middle bit is, which we can count. It's got to be 4 squares. So the total area is going to be 1.5 plus 1.5 plus 1.5 plus 1.5, which is 6, plus 4. So the area is going to be 10. Another way of doing it is using Pythagoras. So to work out what the length is going to be, so if I imagine this, and this is the length, well, let's use green. This is the length of the square. Well, that's going to be 3, and that's going to be 1. And we want to work out what this is. So using Pythagoras, x squared equals 3 squared plus 1 squared. So x squared equals 10. So x equals root 10. So if that's the length of one of the sides of the square, then the area is going to equal root 10 squared. The square and the square root cancel out, which then leaves us with 10. So it's a couple of ways in which you can work out that answer. So then moving on to question 7, it says here are 4 lines, and it says we've got P, Q, R, S, and it says which of these lines has a gradient of -2. Now, because the gradient is negative, that means that the line is going down. So it's either going to be Q or it's going to be S. Now, the next thing to work out is to actually work out the value of the gradient. So the gradient is the distance up or down or up divided by the distance across. So if looking at question Q or line Q, that's going to be 2/4, which is a half. So that number doesn't match up. Whereas with S, it's going to be 4/2, which is 2. And again, both of those two are going to be negative because the line's going down. So the correct answer is S. Moving on to question 8, it says that here is a line, and it says work out the gradient of this line. So again, what you want to do here is pick 2 nice coordinates. Oh, don't know what's happened there. And so here are 2 nice coordinates. I'm going to go for this one and this one. Then if we turn that into a right angle triangle, now we know it's going to have a positive gradient because the line's going up and the distance up over the distance across. So the gradient is going to be 1/3. Again, another coordinate you could have had is this one here and that one there, in which you could have had the same triangle, or you could even have a big triangle of this here. And that's going to be 2, that's going to be 6. So it's 2/6, but it's still going to give you a positive 1/3. Next question then says write down the equation of the line. Well, we know that m, which is the gradient, is 1/3, and the y-intercept of this line is at 2. So c equals 2. So if we substitute those numbers into the formula, we get y equals 1/3 x, which will be worth the mark, and c, which is 2. Now you could even write the equation as 2y equals x plus 4, but I would say that there is probably the most popular answer. Moving on to question 9, it says the graph of y equals x is shown. Work out the equation of the line that is perpendicular to y equals x and passes through the point 4. Now for this, because the gradient of this line is 1 equals 1, then a perpendicular gradient, the perp gradient, is therefore going to be -1 over the gradient of the line that you're wanting. So it's actually going to equal minus 1. Then from this, we've got y equals minus 1x plus c. So from this, what you then want to do is substitute those coordinates of 4, 4 into this equation. So here we've got x equals 4 and y equals 4. So 4 equals minus 1 times 4 plus c. We want to work out what c is. So 4 equals minus 4 plus c. So c equals 8. So from this, what we've then got is this is our m. So m equals minus 1 and c equals 8. So we then just need to write down the equation of the line of y equals mx plus c. So we've got y equals minus 1x plus 8. Or you could write it as y equals minus x plus 8. Or you could write it as x plus y equals 8. So any of those would be absolutely fine for the full marks. Then moving on to question 10, it says A has a coordinate of 3, 4 and B has a coordinate of 1, 2 are shown on the grid. Work out the equation of the line that passes through A and B. Give your answer in the form of y equals mx plus c. So for this, what we need to do is I would probably recommend that you join those lines up. And let me just do just that. And again, what you want to do is you want to work out the gradient of that line and the y-intercept. So we can see that the y-intercept is at 1, even though my graph might suggest it's slightly below. So here we've got c equals positive 1. So what we then need to do is work out the gradient. So if I turn that into a right angle triangle, distance there is 2, 2. So here we've got m equals 2 over 2. And I know it's going to be positive because the blue line's going up. That's going to equal positive 1. So m equals 1. So we've got y equals mx plus c. So the answer then is going to be y equals m, which is 1, x plus c, which is 1. Or you could write it as y equals x plus 1. Now moving on to our last question, it says that C is at the coordinate of 2, 3 is shown on the grid. Work out the equation of a line that passes through C with a gradient of minus 3. So for this, there's a couple of ways in which we can do this. Well, we know that m equals minus 3. I wrote C4, let's go with that. And what we need to do is work out the y ordinate. Now C has got the coordinate of 2, 3. So if we've got y equals mx plus c, now we know that m equals minus 3. So if I substitute that in, so I've got minus 3x plus c equals y. Now this coordinate here is x value and this is my y value. So when y equals 3, so I get 3 equals, and then bracket minus 3 times x, which in this case is 2, plus c. So I've got 3 equals minus 6 plus c, so c equals 9. And then using those two markers there, I can then write down the equation. So it's going to be minus 3x plus 9. And there is my final answer.